Hi, welcome to Concept Based. I'm John Hepworth, and this is another one for Year 11 Advanced students. This is in the Trigonometry section, so we are still in Trigonometry and measures of angles, and we're now in the Radians section. So my previous video was about radians and what defines them, and this is a question that actually relies on a couple of formulas to be able to solve. So let's have a look at this one. Now in this video, I don't want to just solve the question. As you may have noticed from a lot of my videos, I don't just solve the question in these long form YouTube videos, just in my reels. On these YouTube videos, what I want to do is try and explain what's going on with the formulas that we're using, and obviously some of the errors and problems that you can run into. So with the radians section, there's actually a couple of formulas that come to us in this section that are specific to radians. So if we have a look at the formula sheet, we have this whole section for trigonometric functions. Now, almost any of the formulas that you have on here, if you have your calculator set in degrees mode and you use degrees in the formula, it will work. If you have your calculator set in the radian mode and you use radian in the formula, it will work, except 2. So you need to be very careful that you're aware of the fact that there are 2 formulas that are specific to having the angle in a radian, and that's this one here and here. It's not going to allow me, I'm writing in white, that's not going to be visible. Let's see if I can make that visible. Right? So there and there, these 2 formulas, L equals R theta and A equals a half R squared theta, they're specific to radians. Now, once again, they're on the formula sheet, so you don't have to remember them, so that's nice. But you do need to be aware of what the formula is doing, because you need to be aware, obviously, that these are radian formulas. So let's have a look at the first one, L equals R theta. So L equals R theta is related to this question because the L that it's talking about is the arc length, the R is the radius, and the theta is the angle in radians. Now let's just see from the definition that we made in the previous video if this makes sense. So if I had a radius of 1 and I had an angle, a radian angle of 1, what would that result in? Well, that would result in an arc length of 1. That's what defines this whole idea of radians, right? That 1 radian will take 1 radius and place it around as an arc length. So if we're looking at this and we go, well, what would 2 radians do? So if we now go and draw 2 radians in, well, that's obviously going to take us around an amount, and we're going to get around a total of 2 is going to be the arc length. So the angle is sort of equal to the length, but that's because we're in a radius of 1 circle. It will be different if the radius is different. But you can see the length of the arc is a multiple of the radius and the angle in radians. So however big the radius is, if we multiply that by the angle in radians, it will tell us how far we're going around that circle. And therefore, we get that first formula, L equals R theta, right? The arc length is equal to the radius times how big the radian angle is, because that's how far we've got to go around the circle. Cool. So that makes sense. What about the next one? A half R squared theta. So this one is more about the second part of this question, a sector. So if we are talking about a radius here, and we're trying to work out the area of this sector, we would need to take into consideration, essentially, well, what fraction of this circle is this sector? So how big is the circle? Well, the circle, we've always known that. The whole circle, let's say area of the entire circle, equals pi r squared. And the fraction that we have in this circle that is lit up in the sector is just the same way as finding the fraction as we have in the past of any sector. The fraction is going to, so I'm just going to say sector is equal to theta in radians, and this is why it has to be in radians, divided by 2 pi. If you divided by 360, it would change this equation, this formula. So because it specifically is being divided by 2 pi, theta over 2 pi, where 2 pi is the entire circle, this formula is specific to radians, pi r squared. And so now we get pi cancelling with pi. The 2 is on the bottom, so we have a half theta r squared, or a half r squared theta, as it's written, pardon me, on the formula sheet. So that's where the two formulae come from. Two formulas, two formulae, two formulize. It's definitely not that. So that's where they come from. Okay, so now let's go and have a look at a question and let's try and utilize them. So here's our question. Given the following diagram, find the area of the shaded sector. So this is a two-part question, uses both formulas. If we want to find the area of this sector, I'll just get rid of this so we've got some working out space. If we want to find the area of this sector, we've learned that it's a half r squared theta. But we notice that in our sector here, we don't have a theta. We don't know what it is. We need to work that out. So we can work that out from our L equals r theta equation. Because in this one, we have an L, a arc length, and we have a radius of 2. And so we can find theta. So 3 divided by 2 equals theta, and therefore theta equals 1.5. Okay, so now that we've got our theta equals 1.5, we can go and place that up into our area formula. So area equals a half times radius squared, 2 squared, times our theta, 1.5 radians, 1.5, right? Radians, not a bigger angle than that. It's 1.5 is a big angle in radians, equals, so 2 squared is 4, half of 4 is 2, and 2 lots of 1.5 is 3, and therefore whatever the units are that are given in the question, possibly centimeters, it would be 3 square centimeters. And so there it is, the use of two different formulas, but most importantly, using that trigonometric functions formula sheet section effectively. All of the sine rule, cosine rule, trig rules, all of those. If your calculator's in degrees, you can use degrees. If it's in radians, you can use radians. But these two formulas, L equals r theta and A equals a half r squared theta, you have to use radians for them to work.